So today we're going to take a look at identifying if lines are parallel or perpendicular. In one of our last lessons, we learned that parallel lines have the slopes are the same, right? They're equal to one another. And perpendicular lines have opposite reciprocals. Now, sometimes instead of saying opposite reciprocals, we say negative reciprocals. So what that really means for us is if we're dealing with a line that has a slope of 1/2, a parallel line is also going to have a slope of 1/2, right? These two lines would be parallel because they have the same slope. Our opposite reciprocals, again, just a quick refresher, if I have 1/2, that means the perpendicular slope is going to be -2, right? -2/1, or just -2. So opposite reciprocal, different sign, flip the fraction, parallel, they are the same slopes. They must be equal. Now, what I want to kind of bring back to you guys is the equations of a line. So I think most of us are really super familiar with y equals mx plus b, which is likely what we'll be using mostly today. But I am going to start to introduce this y minus y1 equals m times x minus x1 form of the line, which is the point slope form of the line. Ultimately, I think it's easier to work with, even though it's technically a longer formula, but it does make it a little bit easier to work with. Now, for the slope-intercept form, right, that y equals mx plus b, one of the biggest keys for us is that the m, right, is your slope. Not the x, but the m, right, the number in front of the x. Same thing over here with the point slope. If you're dealing with this type of equation, the m is in front of the x parentheses. So what we're going to do today is compare lines, right, equations of lines, and try and find out parallel or perpendicular slopes, and try and analyze these different lines. So a couple examples for us to take a look at. First one says, what is the slope of a line perpendicular, right? The key is we want a perpendicular slope to the line whose equation is 5x plus 2y equals 10. Now, the thing is, in the form that we have, it's not very recognizable for us to figure out what the slope is. So what we want to do first here is get this thing into a y equals mx plus b form. So I'm going to take my 5x plus 2y equals 10, and I'm going to solve for x. So first thing I'll do is I'll move the x over to the other side. So I'll end up with 2y is equal to negative 5x plus 10. I like to keep that x up front just to keep that y equals mx plus b form. And then we'll divide both sides by 2 here. And when you divide both sides by 2, just make sure you divide everything by 2. So our final equation is y equals negative 5 over 2x plus 5. Now, for me to find a perpendicular slope, I'm going to have to take the slope of the line, which is negative 5 over 2, and I'm going to have to find the opposite reciprocal. So my perpendicular slope would be 2 over 5, positive 2 over 5. All right, for our second example, we're going to take a look at the slope of a line parallel to a different line. So same model, but the difference is we're looking for same slopes this time instead of those opposite reciprocals. So we're going to take our 3y equals negative 2x plus 5. And again, our goal is to get this in y equals form. Now this one's a little bit easier. We just have to divide everything by that 3. So we get the line y equals negative 2 over 3x plus 5 over 3. It's okay to leave that as a fraction. And it's okay if that fraction is like a repeating decimal or something. Totally fine. So in this case, we want a parallel line. So if I want to take my slope, which is negative 2/3. So my parallel slope is also going to be the same, negative 2/3. Right, so parallel is the same, perpendicular, that opposite reciprocal. And the third thing that I'll kind of be asking you to do here is I'll give you two different lines and then ask you to decide if they're parallel, if they're perpendicular, or simply neither, right? Both things aren't true. They're just two lines that happen to intersect. So we kind of have that same issue here. We're going to take these lines, we want to get them into that y equals mx plus b form. So 6x plus 3y is equal to 12. And as we're solving, as we're working towards this, right, we're going to get it into that y equals form. So we end up with 3y equals negative 6x plus 12. We divide both sides by 3 here. And we get y equals negative 2x plus 4. right? So our slope here, we're going to kind of pinpoint the slope. Our slope is -2, and we're going to have to compare it to the slope on the other line. So the slope of my other line, I'm going to take my 5x plus 7y equals 14. And I'm going to do that same thing where I get it in that y equals form. So I'm going to subtract my 5x over to both sides. We have 7y is equal to negative 5x plus 14. And divide both sides by 7. We get y equals negative 5 over 7x plus 2. Now, the thing with this equation is the slope is negative 5 over 7. So we end up with this thing where, right, the slopes are not equal. They're not opposite reciprocals. So really, these two lines fit the neither category. So we're going to say the slopes intersect. The slopes intersect at an angle other than 90 degrees and are not, right, and they're not parallel, right? If they're intersecting, we know that they're not parallel because the slopes are not opposite reciprocals, or I'm going to say perpendicular, or not opposite reciprocals. And we'll also say and are not equal. And so we just want to kind of come up with that summative statement, what's going on here. If the slopes happen to be parallel, we'd say, okay, they're the same slopes, so the two lines would be parallel. Same thing with the idea of perpendicular. All right, take a look at some of the practice and let me know if you guys have any questions.